Okay, here we go with a standing waves question. Pre-warning, I'm fairly certain I've taught this incorrectly due to some naming conventions. We'll talk about it together in a second. Pause the video, press play when you are ready to see an explanation. Okay, here we go. So, like I say, I have a confession to make. I think I probably taught this wrong, so my apologies to those of you I've taught. I think it's not necessarily the physics is wrong, it's the naming convention. Let's come on to that in a second. We're looking here at closed at one end and hence open at the other, and so hopefully you're looking at this kind of setup. We've got our resonant modes, so we've got our first mode here, second, third, etc. Now, where I think this gets confusing is not necessarily the formation of the wave. So we should have a node here and an antinode, a position of zero displacement and a position of maximum displacement. What the problem is here is if I think we were looking for the fifth harmonic. Now, if previously I would have gone down to here, this would have been my fifth harmonic, 1, 2, 3, 4, 5. However, for closed and closed open, or these sort of fixed free boundaries, it seems that the naming convention is slightly different. For this particular case, and it does seem to be a very unique one, what we tend to do is think about in terms of quarters. So this would be n equal to 1, because there's 1/4 of a wave. Here we have 1, 2, 3/4 of a wave, so this is actually n equal to 3. This is the third harmonic. Ergo, there is no second harmonic in the open-closed condition. That means that our fifth harmonic, 1, 3, 5, you guessed it, is here. There are 5/4 of a wave here. Now, this is where I think it's a bit confusing. I think previously I would have referred to this as a third harmonic, and I'm definitely not the only physics teacher to do so. I'm wondering if this is an IB thing. If anybody has any sort of particular viewpoint on this, please let me know. But we're going to go with this for now. Okay, so what we've got here is the full length of the container L is this one here. Well, L, you can see here, is we've got 1¼ wave. So it's fair enough to say that L is 5/4 of a wavelength. We want to know what the wavelength is, so all we have to do is rearrange that to get 4/5. Now, what I think it is worth us doing, so the answer here is C. Now, the reason I've come to this is because I think I did sit here thinking about this, and I may have just missed something completely obvious. If we went with this one down here, we could think about this. We're going to go for, this is 4/4, this would be 8/4, this would be 9/4. So we'd be looking for a factor of, instead of a 5 up here, we'd be going for 9 there, so we'd have 4/9. Now notice none of these are options, which is why the answer here is C. Okay, I appreciate that's very, very confusing. I probably need to redo my video on standing waves. I'm sure we can work that out. But just so you're aware, when we're looking at this open-closed condition, then our first, we only have a first mode, third, and then fifth, and this would be seventh and ninth. Okay, again, apologies for the confusion. Please let me know if you need any clearing up on that.